In this lesson, we're going to identify intercepts of polynomial functions in factored form. So you'll be given some functions that are already factored, and you're going to be asked to find the intercepts, both the x and the y-intercept. Let me just remind you real quickly what we mean by intercepts. So notice I have this polynomial function. So this is a polynomial function. Remember, the characteristic of a polynomial function is that you have a smooth curve. See a smooth curve like this, and notice the turning points. Turning points are smooth. See, this is a turning point. That's where it turns. That's where it goes from decreasing to increasing and then increasing to decreasing. See, it's a smooth turning point. Smooth turning point. All right, so that's a characteristic of a polynomial function. Now, before I go on, remember though that we also talked about these being a polynomial function. So don't let this throw you off. So we have a horizontal line is a polynomial function. It's a constant function. So a constant function is also a polynomial function. A linear function is also a polynomial function. All right, so just keep that in mind. But in particular, when we think of polynomial functions, we think of something that looks like this, where it's a smooth curve. Okay, and let me just say this. So these are polynomial functions, right? Polynomial functions. And this right here is not, right here, that absolute value, that's not a polynomial function. And the reason, not a polynomial function, and the reason is because this turning point is a sharp turning point, a sharp turning point. So a sharp turning point is not a smooth turning point. A polynomial function, you have a smooth turning point. So that's why this is not a polynomial function, because that sharp turning point. It decreases, then all of a sudden, very sharply, it increases. It's not smooth. Okay? All right. So notice in this graph, there are, remember the x-intercepts is where a function crosses the x-axis. And so there's one x-intercept, two x-intercepts, 3, 4, and 5. So this function has 5 x-intercepts, right? And then the y-intercept is where the graph crosses the y-axis. And so notice it crosses the y-axis here. So this point right here happens to be both, in this case, the origin. The origin in this case happens to be both the x and a y-intercept. But there's 1, 2, 3, 4, 5 x-intercepts. So there are 5 x-intercepts. 5 x-intercepts. And then 1 y-intercept. Okay, so remember a function cannot have more than one y-intercept. So that's why you only see one here. You can't have 2 y-intercepts, then it would no longer be a function. All right, but it can have multiple x-intercepts, but only one y-intercept. All right, so that's what we mean by x and y-intercepts. So number one, let's look at this example. So let's suppose, and the directions will say find the x and y-intercepts, find the intercepts of each function. All right, so find the x-intercepts of each function. So here's number one. It's already going to be in factored form. All right, so let's say we had this. We had f of x equal x plus 2 times x minus 1 times x minus 3. Okay, so now you see it's already in factored form, right? Factored form. So this function has been factored for you. So to find the x-intercepts, remember to find the x-intercepts, you're going to set the function equals 0. So to find the x-intercepts, you let y equals 0. Remember that? And f of x means the same thing as y. So I'm going to set this product equal to 0. X plus 2 times x minus 1 times x minus 3 equals 0. And then remember the zero factor property? I have three factors whose product is 0. So that means that one of those factors has to be 0. So we set each factor equal to 0. X plus 2 equals 0. X minus 1 equals 0. X minus 3 equals 0. All right, and then we're going to solve each linear equation. So I get x to be negative 2, x to be 1, x to be 3. So those are your x-intercepts. Now, you're probably asked to write this as an ordered pair. So as an ordered pair, always follow directions. If it says write as an ordered pair, make sure you do that. So an ordered pair, you'll say -2, 0, 1, 0, and then 3, 0. So those are your x-intercepts. Okay? Now to find the y-intercept, you're going to let x equal 0. And so when I let x equal 0, I'll go back to my function, and wherever we see the variable x, I substitute 0. So I get y equal, remember I'm finding the y-intercept, so y equals 0 plus 2 times 0 minus 1, and then I go here and I substitute 0 for x, 0 minus 3. So that's going to equal 0 plus 2 is 2, 0 minus 1 is a -1, and then 0 minus 3 is a -3, right? And so 2 times -1 is a -2, so that's -2, and then -2 times a -3 is a +6. So my y-intercept, the y-intercept is 6. So as an ordered pair, you're going to say, remember x is 0, y is 6. So make sure you write it correctly, 0, 6. All right, so that's how you find intercepts of functions that's already been factored for you. All right, now in the graph, here's what the graph looks like, just to show you. So here's the graph of this function, and hopefully you can see it well. So here's the graph of this function, so this polynomial function. See smooth curve, right? Smooth turning point, smooth turning point. Those 3 points here are your x-intercepts, which we just found. So your x-intercepts are -2, 1, and 3. So here's -2, here's 1, here's 3, correct? And then here's your y-intercept. You can't see it, but that's a 6 right here. So the graph crosses the y-axis at 6. So you see 6 right here? So that's what this is. So that's the graph. All right. And when you get into calculus, you'll be able to graph this. You'll be able to graph something like this and make it look just like this, because you'll use derivatives to help you to find these turning points. All right. So that is how you're going to find x and y intercepts of a function that's in factored form. So let's look at another one real quick. So it's pretty easy, right? Pretty easy to find the x and y intercepts of functions that are already factored. So number 2, let's say we had f of x equal 2 times x plus 5 times x plus 1 times x minus 4. All right, and notice in this particular one I have 4 factors. I have this 2, this numerical factor, and then all the other factors are variable expressions. X plus 5, x plus 1, x minus 4. And so if I want to find the x-intercept, I'm going to set this function equal to 0. So let's go ahead and find the x-intercept. All right, so to find the x-intercept, you're going to let y equal 0. So you're going to set f of x equal to 0. So all of this is going to be equal to 0. So 2 times x plus 5 times x plus 1 times x minus 4 equals 0. What I want you to remember, though, is this. So this 2 right here is not going to give you anything in terms of x-intercepts, this factor, because this factor is not a variable expression. It's just 2. So if you set each of those factors equal to 0, obviously that's not going to make any sense, right? So you just throw that away. You're not going to use this factor to find any x-intercepts because there's no variable here. But you're going to use them for these, though. So these factors have variable expressions. So you're going to set each of those equal to 0. So you have x plus 5 equals 0, x plus 1 equals 0, and then x minus 4 equals 0. So using the 0 factor property. And then you solve each of those linear equations, you get x to be -5, x to be -1, and x to be 4. You will be asked to write this as an ordered pair probably, so make sure you follow directions. So as an ordered pair, my x-intercepts are -5, 0, -1, 0, and then 4, 0. All right? And then let's go ahead and find the y-intercept. Find the y-intercept. And remember, to find the y-intercept, you're going to let x equal 0 to find the y-intercept. So you go back to your function. Wherever you see the variable x, you're going to substitute 0. So I have f of 0, which is the y-intercept, which is y, is going to equal 2, don't forget to put the 2 there, 2 times 0 plus 5 times 0 plus 1 times 0 minus 4. Okay, don't forget the 2. The 2 is part of your function, so you must write it. Equal 2 times 0 plus 5 is 5, 0 plus 1 is 1, 0 minus 4 is a negative 4. And so let's go ahead and multiply this out. 2 times 5 is 10, times 1 is 10, right? And then 10 times a negative 4 is a negative 40. Negative 40. So my y-intercept as an ordered pair is 0, negative 40. So you have 3 x-intercepts and then 1 y-intercept. And here's what the graph looks like, just to show you. Here's the graph. So notice polynomial function, smooth turning points, smooth turning points. See that? And notice in this case there are 2 turning points. 1, 2. So here are your x-intercepts. Negative 5, right here. Negative 5, negative 1, and 4. 4, negative 1, negative 5. And you see the y-intercept? Your y-intercept's negative 40. That's why the graph crosses the y-axis at negative 40. All right, so there's a graph. And again, when you get into calculus, you'll be able to graph this. You'll be able to graph something that looks just like this by using derivatives to help you. All right, so that was number 2. Let's look at number 3. Number 3. All right, so number 3, we have this function. We have x plus 2 times x minus 1 squared. So notice, I want you to notice something. I want you to really notice that there are 3 factors here. And not 2. There are 3 because this x minus 1 is listed twice. See that? So note f of x equal x plus 2 times x minus 1 times x minus 1. So there are really 3 factors, right? Okay. So you want to find the x-intercepts. And so to find the x-intercept, you're going to set each of those factors equal to 0, either here or here. It does not matter. So let's go ahead and find the x-intercepts. So find the x-intercepts. Find the x-intercepts. You're going to let the function equal 0. You're going to let y equal 0. So I said all this equals 0, either this or this. It does not matter. So I want you to see something. If I do the bottom one here, I get x plus 2 times x minus 1 times x minus 1 equals 0. So I have 3 factors whose product is 0. So I'm going to say each one equal to 0. X plus 2 equals 0. X minus 1 equals 0. I want you to notice something, though. So notice these two are the same, right? These two are the same. So don't list them twice because they give you the same x-intercept. So just list it once. So just list it once. So you're only going to have 2 x-intercepts. Two distinct x-intercepts. Okay, that's all you're going to have. So the graph's going to cross or touch, I'm going to use the word touch here, the x-axis twice, 2 times. So once when x is negative 2 and once when x is 1. So your x-intercepts as ordered pair, your x-intercepts are negative 2, 0 and 1, 0. All right, now let's go ahead and find the y-intercept. Find the y-intercept. You're going to let x equal 0. And it doesn't matter whether you go here or here. I'm going to go to the original. So when I let x equal 0, I get f of 0, which is y, is going to be 0 plus 2 times 0 minus 1 squared. Okay? And then 0 plus 2 is 2. 0 minus 1 is a negative 1, but I'm squaring that, so don't forget to square it. So I get 2 times, and a negative 1 times itself is a positive 1, which gives me 2. So my y-intercept is the ordered pair 0, 2. Okay? So I have 2 x-intercepts and then 1 y-intercept. Let me show you what the graph looks like. So here's the graph. Notice my x-intercepts, negative 2 and 1, right? Remember, negative 2 and 1. Now remember, an x-intercept is where the graph crosses or touches. Crosses or touches the x-axis. So it can touch. It doesn't necessarily have to cross. It can touch. Even if it touches, that point is considered the x-intercept. Crosses, touches. Okay? Now, see how it touches? That touches right here has to do with the idea of multiplicity, which you're going to learn in the next lesson. So this exponent 2 right here, the fact that it's even, the fact that this is even has to do with the touching, and you're going to learn that in another lesson. But here are your two x-intercepts, -2 and 1, and here's your y-intercept at 2. So there's the graph. And notice it is a polynomial function. It's a smooth curve. See that? All right, so that's all I wanted you to know about this lesson. So this lesson was where you were finding, where you were identifying the intercepts of polynomial functions in factored form.